The Bell UH-1 Iroquois is a military helicopter powered by a single turboshaft engine, with two-bladed main and tail rotors. The helicopter was developed by Bell Helicopter to meet the United States Army's requirement for a medical evacuation and utility helicopter in 1952, and it first flew on the 20th of October 1956. Ordered into production in March 1960, the UH-1 was the first turbine-powered helicopter to enter production for the United States military, and more than 16,000 have been built. The first combat operation of the UH-1 was in the service of the U.S. Army during the Vietnam War. The original designation of UH-1 led to the helicopter's nickname of UH. In September 1962, the designation was changed to UH-1, but UH remained in common use. Approximately 7,000 UH-1 aircraft saw service in Vietnam. Development. In 1952, the Army identified a requirement for a new helicopter to serve as medical evacuation, instrument trainer, and general utility aircraft. The Army determined that current helicopters were too large, underpowered, or complex to maintain easily. In November 1953, revised military requirements were submitted to the Department of the Army. 20 companies submitted designs in the bid for the contract, including Bell Helicopter with the Model 204 and Kaman Aircraft with a turbine-powered version of the H-43. On 23 February 1955, the Army announced its decision, selecting Bell to build 3 copies of the Model 204 for evaluation, designated as the XH-40. Model 204 powered by a prototype Lycoming YT-53L1 engine producing 700 shp. The XH-40 first flew on 20 October 1956 at Fort Worth, Texas, with Bell's chief test pilot, Floyd Carlson, at the controls. 2 more prototypes were built in 1957, and the Army had previously ordered 6 YH-40 service test aircraft, even before the first prototype had flown. In March 1960, the Army awarded Bell a production contract for 100 aircraft, which was designated as the HU-1A and officially named Iroquois after the Native American nations. The helicopter quickly developed a nickname derived from its designation of UH-1, which came to be pronounced as UH. The reference became so popular that Bell began casting the name on the helicopter's anti-torque pedals. The official U.S. Army name was almost never used in practice. After September 1962, the designation for all models was changed to UH-1 under a unified Department of Defense designation system, but the nickname remained. While glowing in praise for the helicopter's advances over piston-engined helicopters, the Army reports from the service desk of the YH-40 found it to be underpowered, with the production T-53L1A power plant producing a maximum continuous 770 shaft horsepower. The Army indicated the need for improved follow-in models even as the first UH-1s were being delivered. In response, Bell proposed the UH-1B, equipped with the Lycoming T-53L5 engine producing 960 shp and a longer cabin that could accommodate either 7 passengers or 4 stretchers, and a medical attendant. Army testing of the UH-1B started in November 1960, with the first production aircraft delivered in March 1961. Bell commenced development of the UH-1C in 1960 in order to correct aerodynamic deficiencies of the armed UH-1B. Bell fitted the UH-1C with a 1,100 shp T-53L11 engine to provide the power needed to lift all weapons systems in use or under development. The Army would eventually refit all UH-1B aircraft with the same engine. A new rotor system was developed for the UH-1C to allow higher airspeeds and reduce the incidence of retreating blade stall during diving engagements. The improved rotor resulted in better maneuverability and a slight speed increase. The increased power and a larger diameter rotor required Bell's engineers to design a new tail boom for the UH-1C. The longer tail boom incorporated a wider chord vertical fin on the tail rotor pylon and larger synchronized elevators. Bell also introduced a dual hydraulic control system for redundancy as well as an improved inlet filter system for the dusty conditions found in Southeast Asia. The UH-1C fuel capacity was increased to 242 US gallons, and gross weight was raised to 9,500 pounds, giving a nominal useful load of 4,673 pounds. UH-1C production started in June 1966 with a total of 766 aircraft produced, including 5 for the Royal Australian Navy and 5 for Norway. Model 205. While earlier short-body Hueys were a success, the Army wanted a version that could carry more troops. Bell's solution was to stretch the HU-1B fuselage by 41 in and use the extra space to fit 4 seats next to the transmission, facing out. Seating capacity increased to 15, including crew. The enlarged cabin could also accommodate 6 stretchers and a medic, 2 more than the earlier models. In place of the earlier models' sliding side doors with a single window, larger doors were fitted which had 2 windows, plus a small hinge panel with an optional window, providing access to the cabin. The doors and hinged panels were quickly removable, allowing the Huey to be flown in a doors-off configuration. The Model 205 prototype flew on the 16th of August 1961. 7 pre-production prototype aircraft had been delivered for testing at Edwards AFB starting in March 1961. The 205 was initially equipped with a 44-foot main rotor and a Lycoming T53L9 engine with 1,100 shp. The rotor was lengthened to 48 feet with a chord of 21 in. The tail boom was also lengthened in order to accommodate the longer rotor blades. Altogether, the modifications resulted in a gross weight capacity of 9,500 pounds. The Army ordered production of the 205 in 1963, produced with a T53L11 engine for its multi-fuel capability. The prototypes were designated as YUH-1D and the production aircraft was designated as the UH-1D. In 1966, Bell installed the 1,400 shp Lycoming T53L13 engine to provide more power for the aircraft. The pitot tube was relocated from the nose to the roof of the cockpit to prevent damage during landing. Production models in this configuration were designated as the UH-1H. Marine Corps. In 1962, the United States Marine Corps held a competition to choose an assault support helicopter to replace the Cessna 01 fixed-wing aircraft and the Camano H-43D helicopter. The winner was the UH-1B, which was already in service with the Army. The helicopter was designated the UH-1E and modified to meet Marine requirements. The major changes included the use of all-aluminum construction for corrosion resistance, radios compatible with Marine Corps ground frequencies, a rotor brake for shipboard use to stop the rotor quickly on shutdown, and a roof-mounted rescue hoist. The UH-1E was first flown on 7 October 1963 UH-1C, and deliveries commenced the 21st of February 1964, with 192 aircraft completed. Due to production line realities at Bell, the UH-1E was produced in two different versions, both with the same UH-1E designation. The first 34 built were essentially UH-1B airframes with the Lycoming T53L11 engine producing 1,100 shp. When Bell switched production to the UH-1C, the UH-1E production benefited from the same changes. The Marine Corps later upgraded UH-1E engines to the Lycoming T53L13, which produced 1,400 shp. After the Army introduced the UH-1M and upgraded the UH-1C helicopters to the same engine. Air Force. The United States Air Force's competition for a helicopter to be used for support on missile bases included a specific requirement to mandate the use of the General Electric T-58 turboshaft as a power plant. The Air Force had a large inventory of these engines on hand for its fleet of HH-3 Jolly Green Giant rescue helicopters, and using the same engine for both helicopters would save costs. In response, Bell proposed an upgraded version of the 204B with the T-58 engine. Because the T-58 output shaft is at the rear, and was thus mounted in front of the transmission on the HH-3, it had to have a separate offset gearbox at the rear and shafting to couple to the UH-1 transmission. Twin-engine variants. The single-engine UH-1 variants were followed by the twin-engine UH-1 and twin-hui, and years later the UH-1Y Venom. Bell began development of the UH-1N for Canada in 1968. It changed to the more powerful Pratt & Whitney Canada PT-60 twin-engine set. The U.S. also ordered the helicopter, with the U.S. Air Force receiving it in 1970. Canada's military, the U.S. Marine Corps, and the U.S. Navy first received the model in 1971. In 1996, the USMC began the H-1 upgrade program by awarding a contract to Bell Helicopter for developing the improved UH-1Y and R-1Z variants. The UH-1Y includes a lengthened cabin, 4-blade rotor and two more powerful GET-700 engines. The UH-1Y entered service with the USMC in 2008. Design. The UH-1 has a metal fuselage of semi-monocoque construction with tubular landing skids and two rotor blades on the main rotor. Early UH-1 models featured a single Lycoming T-53 turboshaft engine in versions with power ratings from 700 shp to 1,400 shp. Later UH-1 and related models would feature twin engines and 4-blade rotors. All aircraft in the UH-1 family have similar construction. The UH-1H is the most produced version, and is representative of all types. The main structure consists of two longitudinal main beams that run under the passenger cabin to the nose and back to the tail boom attachment point. The main beams are separated by transverse bulkheads and provide the supporting structure for the cabin, landing gear, underfloor fuel tanks, transmission, engine, and tail boom. The main beams are joined at the lift beam, a short aluminum girder structure that is attached to the transmission via a lift link on the top and the cargo hook on the bottom, and is located at the aircraft's center of gravity. The lift beams were changed to steel later in the UH-1H's life, due to cracking on high-time airframes. The semi-monocoque tail boom attaches to the fuselage with 4 bolts. The UH-1H's dynamic components include the engine, transmission, rotor mast, main rotor blades, tail rotor drive shaft, and the 42-degree and 90-degree gearboxes. The transmission is of a planetary type and reduces the engine's output to 324 revolutions per minute at the main rotor. The two-bladed, semi-rigid rotor design, with pre-coned and underslung blades, is a development of early Bell model designs, such as the Bell 47, with which it shares common design features, including a dampened stabilizer bar. The two-bladed system reduces storage space required for the aircraft, but at a cost of higher vibration levels. The two-bladed design is also responsible for the characteristic "hooey thump" when the aircraft is in flight, which is particularly evident during descent and in turning flight. The tail rotor is driven from the main transmission via the two-directional gearboxes, which provide a tail rotor speed approximately 6 times that of the main rotor to increase tail rotor effectiveness. The UH-1H also features a synchronized elevator on the tail boom, which is linked to the cyclic control and allows a wider center of gravity range. The standard fuel system consists of 5 interconnected fuel tanks, 3 of which are mounted behind the transmission and 2 of which are under the cabin floor. The landing gear consists of 2 arched cross tubes joining the skid tubes. The skids have replaceable sacrificial skid shoes to prevent wear of the skid tubes themselves. Skis and inflatable floats may be fitted. Internal seating is made up of 2 pilot seats and additional seating for up to 13 passengers accrue in the cabin. The maximum seating arrangement consists of a 4-man bench seat facing rearwards behind the pilot seats, facing a 5-man bench seat in front of the transmission structure, with 2 2-man bench seats facing outwards from the transmission structure on either side of the aircraft. All passenger seats are constructed of aluminum tube frames with canvas material seats, and are quickly removable and reconfigurable. The cabin may also be configured with up to 6 stretchers, an internal rescue hoist, auxiliary fuel tanks, spotlights, or many other mission kits. Access to the cabin is via 2 aft sliding doors and 2 small, forward hinged panels. The doors and hinged panels may be removed for flight, or the doors may be pinned open. Pilot access is via individual hinged doors. While the 5 main fuel tanks are self-sealing, the UH-1H was not equipped with factory armor, although armored pilot seats were available. The UH-1H's dual controls are conventional for a helicopter and consist of a single hydraulic system boosting the cyclic stick, collective lever and anti-torque pedals. The collective levers have integral throttles, although these are not used to control rotor RPM, which is automatically governed, but are used for starting and shutting down the engine. The cyclic and collective control the main rotor pitch through torque tube linkages to the swash plate, while the anti-torque pedals change the pitch of the tail rotor via a tensioned cable arrangement. Some UH-1Hs have been modified to replace the tail rotor control cables with torque tubes similar to the UH-1N twin